Welcome to 3.9 Logistics Growth and a Function to a Function. These are both large problems that will for sure be on any upcoming test. Go ahead and take a moment to write down this first example. Welcome back. All right, estimate the initial number of students infected. Okay, that would be initial, would be when time is 0, the beginning of time. I was actually there at the beginning of time. That's how old I am. Here we go. That would be P of 0. So you're plugging in P of 0 and calculating that amount. And when you calculate that, you get P of 0 equals 4.743 people, students infected. Really? You don't have 4.743. That would be 5 infected students. Okay, good. Go ahead and try part B. How fast is the flu spreading after 3 days? Please ignore the U being dotted. It just happens. I don't know why. All right. How fast? How fast implies the derivative. It is a rate of change, the speed, how fast. So when I'm looking for speed, I need to take the derivative of this. In order to take the derivative of this, I need to do the quotient rule. That is a 3-point step right there. Low D high minus high D low over low squared. Don't forget that chain rule right here when you're taking the derivative of e to the 3 minus t. All right, how does that simplify? Simplifies to this. So what am I looking for? I'm looking for the maximum value, which means I need to set that derivative equal to 0 over 1 and 1 over 0. Oh, no, I'm sorry. How fast is I'm not looking for the maximum, I apologize. How fast is the flu spreading after 3 days? So I want that rate of change when T is 3. So I would go back and read again the words. So now I'm going to plug in T with the 3 and solve. And when I solve that, I get P prime of 3 is 25. That means that on the 3rd day of the flu, the rate of infection is 25 students per day. All right, part C. Part C is asking, when will the rate spread at its maximum rate? So what I'm going to do is I'm going to look at this. This is logistics growth. This is a carrying capacity model. This number right here is my maximum number. This picture has this graph where it has an asymptote along here and an asymptote along here. And this maximum value is 100. Your fastest rate occurs when P equals the halfway point, when P is 50. That is always true for logistics growth. That is always true for logistics growth. So my maximum rate will occur when P is 50. Therefore, I can plug 50 into this, cross multiply, and solve. And I get that my maximum rate occurs on the 3rd day of the flu and is 25 students per day. Okay. Next question. A function to a function. Guaranteed test question. The derivative of a function to the power of a function, you're going to take the natural log of both sides first. Okay, here's the example. I'm going to give this to you. I want you to write this down and give it a try. Your example, y equals 5x squared plus 3x to the power of sine x. Go ahead, put me on pause, give it a shot. Welcome back. Okay, I just gave you the hint of a lifetime right above there in red. Take the natural log of both sides. That is worth 1 point. Using your log rules now, you can bring sine out of the exponent. Now you're going to take the derivative, and you need to take the derivative from the left to the right all the way through. So the derivative of the natural log of y is 1 over y times dy dx equals first times the derivative of the second with a chain rule plus second times the derivative of the first. That is 4 points in that one step right there. Now, let's simplify that. It doesn't simplify much more than that at all. I'm going to multiply y to the other side. But the final step everyone seems to forget, and that's where I have to take the original function right back here at the beginning and replace that in place of y. It's a 9-point test question. Thank you for joining me.